Going to do another one of these live streams. Live stream a little bit late because this is the only time I have to do homework. In any case, probably only going to do this maybe for like 20-30 minutes. I'm just kind of curious of exploring a use case today. I was hoping to actually finish the Python script for this tool, but I don't think I'm going to finish it. What I'm actually going to do today is explore whether or not I can dig into a different use case in this situation. In the CPIC website, they do talk about different population frequencies. So the percentage population that may have a certain genetic mutation. And I'm kind of curious if I can use that data to populate a Bayesian network or BayesNet to predict the likelihood that, given a patient's ethnicity, what their likely phenotype may be for a given gene or something like that. But I have no idea. So this is just me tinkering. If you're watching to learn something, you may or may not. I might just be struggling. So we will see. I'm going to just share my screen to kick this off. Have some music playing in the background as I try to focus. Okay, here we go. So I have, this is from the CPIC website showing different API calls. On the left is like all of their data models, which is actually quite robust. So you can look up all different information about it. And the one I'm curious about today, since I'm not going to finish the tool today, is actually these, I think it's these, right? These population frequencies. Yeah, something like this. I don't know if it's going to have the information I need, but I'm going to explore this. And then this is the collab. This is where I'm writing all my Python script. So let me start up ChatGPT, because some of the things I'm actually curious about is if you only have the percentages, because I did the API call just now. Actually, let me bring that up. Oh, actually, it's right here. This is the API call for that population frequency table. And it gives me this information right here, which, so there is ethnicity. This is good. And then there's like the gene. Oh, there's actually counts here. That's interesting. Weighted average and average. I guess what the use case would be allowing the clinician to enter, if they're unsure. So this would be the case where it's a brand new patient, have not had any genetic tests yet, but obviously the ethnicity. So they want to prescribe certain drugs because they know whatever disease they might have, and they want to know beforehand. And I don't even know if that would be a scenario, because they would probably order the genetic tests before prescribing a drug. So this is probably an unlikely scenario, but it could be interesting to figure out nonetheless. So maybe something to just try anyways. I just don't know if this is enough information to produce it. The BayesNet model I built before, there's actually rows. So you can actually, I guess you can kind of make this up. Not make it up as in like fake data, but like you have the frequency plus the number of patients. So the number of patients that has it and the number of patients that don't. So I'm just curious if this is enough information to build a BayesNet. So let's take a look. I'm just going to log in real quick. I would like to build, and for folks, anyone, I don't know, anyone that's watching, don't know what a BayesNet is, maybe that's what I can do. ChatGPT can probably explain it better than I can. What is a BayesNet? Just in case folks are watching and don't know what this is. So chatGPT, a Bayesian network or probabilistic graphical model is a probabilistic graphical model that represents a set of variables and their conditional dependencies using a directed acyclic graph and conditional probability distributions. This is a lot of jargon. Basically, it predicts the likelihood of something. So again, if a patient has some ethnicity, we just want to know what are the likely genetic mutations they might have. And then we may be able to preemptively pick the best drugs to use, assuming we have no genetic test results for that patient. But I think in real life, you would be most inclined to order the genetic tests nowadays, but I'm not entirely sure of that either. Maybe it's not as readily available. I feel like it would be, but anyways, perfect. Let's see. If I wanted to build a BayesNet, what information do I need? Would having only the frequencies be sufficient? A set of variables you need to identify so that you want to model and their possible state values. Conditional dependencies. Maybe that is enough. So it would be basically organized by like, for each row would represent the ethnicity. That probably is right, because you want to know every single gene that patient may have a risk of mutation for. So every row will represent an ethnicity, and each column, in this case, would be the variables, would be, and then the percentages of each variable would be the columns. Having only the frequency of might not be sufficient to build a Bayes. Oh, down here. So this is actually what I have. I only have the frequencies, as you would need to know the conditional dependencies between the variables and their prior probabilities. I think they're in, that's probably wrong to say, if they're independent. And the prior probabilities compute conditional. However, the frequencies can be used to estimate, such as independence of variables and conditional dependence, giving the values of the parents. Conditional probabilities. You will need to specify the condition of each variable given its parent. So I have, let me see, what did the data show again? So for every single gene, there's, I don't think it's the gene I'm interested. I want to know the ethnicity first. So African American, CYP2C9. What is the likelihood that they'll have certain phenotypes? I wonder what these other ones do. So this is population view with some aggregate calculations. It is grouped by biogeographical. This part gets a data on all groups that have CYP2C. Oh, this is only CYP2C9? I don't think I realized that. Oh, yeah. Okay. Greater than 1. Alleles with frequencies. This request gets frequency data, but in the context of alleles. So it can be filtered down to just CYP2C19. Gets well in the context of alleles, so it can be filtered down to just 2C19 increase function. I don't think I really understand what they mean by this. Oops, let me just grab this. So I didn't realize until yesterday, or rather today, that you can actually, can I copy? Yeah, nice, you can just copy it. They have some Python code you can start with too, that's already pre-written here. Let me actually do this one down here. The only thing is just, it's not structured in a way that's really usable aside from just grabbing the information, which I don't even think this printed out anything. Nope, didn't print out anything. Well, if CPIC is watching this, I think your thing is incorrect. Let me just I'll just run it on Postman. Let's see. Hopefully it works on Postman. Let's go on CPIC. I'm gonna run a new search. So you can actually check for increase function. I think that's it. Yeah, so their Python script was broken because this works. I'm gonna save this too. This is, what was this called? Alleles with frequencies. Alleles with frequencies. So what does it give you? So you have a gene, you have a functional status, increase function, definitive is assigned. So alleles with frequencies. CYP2C19 with the star 17. Increase function. Oh, this is so cool. So like the percentages in each ethnicity that has increased function. Allele frequency. I wonder which one would be better to use. Frequency label. Let me look at the last one. Frequencies for gene results. This request pulls the summarized frequency data for a gene by result. In this case, phenotype. Setting the frequency parameter to not is null returns only those results which have frequency data available. Is null a special syntax for process, and adding the not flips it. Gene symbol, not is null, order result frequency. For by results. Maybe this is what I'm looking for. Let's see what this gives us. So this one is for, let me read this again. It says frequency data for a gene by result. Results intermediate. So it's for CYP2C19. Maybe I should ask, what is the likelihood that clinicians don't order a genetic test before prescribing a med that they know may be impacted? I wonder if ChatGPT knows this. What is how common is genetic? How common is pharmacogenetic test nowadays? And obviously ChatGPT, oh great. Just do this again. How common is ordering of pharmacogenetic tests when prescribing new medications? Did my thing like error out? How common is the ordering of pharmacogenetic tests for a clinician drugs and medication. I feel like this is going to be so inaccurate. It's becoming more common, obviously, but it is not the standard of care. Maybe that's like typical. The use can help play out across countries, healthcare systems have integrated pharmaceutical sites. The CPIC provides evidence. I'm just going to actually use Google. When common is the ordering of pharmacogenetic tests? Few people receive genetic testing despite a nearly 2.5 times difference between. This is potentially meaningful in estimating the degree of permeation into clinical practice in that 100% of the individuals selected were taking medication appeared in the drug's FDA-approved labeling. The combination of this criteria with the broad set of CPT codes used to depict of any kind cast the widest possible net ceiling effect of the likelihood of receiving. Unfortunately, appear that the ceiling was very low. Behavioral change when. In addition, these results were obtained from the entire population of enrollees. So this is 2021, early 2021, and it may suggest that it's still not that widespread, which I didn't think it was the majority, but like at least for, in this article, they talked about for FDA approved drugs, or drugs to have a FDA label mentioning pharmacogenetics. You would think that it'd be closer, like the majority in those cases. I just want to see, how common it is. And maybe this is a moot point. I should be trying to build. Yeah, maybe there's a moot point. I just want to see if I can build something with this. So maybe there is some value in actually building this part out. Next is like, which one should I use? Like this is for a given gene. Intermediate, likely metabolizer. Example of population view. I'm just gonna look at this one again. Gene, subject. This one might not work because I think what you want to know, or this might work, but you want to actually, you're gonna have to combine multiple queries. We want to know the phenotype, the likely phenotype of a given gene when we have the ethnicity of the patient. So this is definitely not enough information, but this is an aggregate view. So this may be helpful because then we can take these alleles and then match it up with the phenotypes. Because I think this is the one that has the, is it this one? Frequency of gene, or maybe it's this one. I don't know what's the difference between these two tables. Here's the gene name. So this is like the specific functional status. So if you know a gene and this is the status. Where is, what does this say again? Gets frequency data in the context of allele, so it can be filtered down. So maybe it's these two then. And you want to combine, I don't want to build something that runs two queries, one to grab the likelihood that they have a specific allele, and then match it up with what the phenotype is, which would be this one. But this one actually might have the frequencies already too, so maybe I can just use this one. Let's see. Frequency. So you pick a specific gene here. Results. Oh, you know what? These don't even have the alleles. This might be the one that I could use then. Polls the summarizing for a gene by results. Joins the alleles population and alleles frequency. It's also included. This across gets data on all groups that have. This one actually seems like it groups all of them then. This request pulls the summarized frequency for a gene by result. Joins the allele population allele frequency. Yeah, so like this is what we want to know. So when given a particular ethnicity, let me go back to the BaseNet. What, when building a BaseNet in Python, on building a BaseNet, what input variables do I need to give my model? Ugh. I don't know if this is timing out just because there's too many people using ChatGPT. Nodes. You need to specify the nodes in the Bayesian network, which represents the variables or events that you're interested in modeling. Each node should have a unique name and a set of possible states. You need to specify relationships for conditional probabilities. You can use knowledge of the domain of data, conditional probability tables. Okay. Maybe I'll just ask it to see if we can ask it to build it. Okay. Let's see. Let's see what data they have here. So yeah. Here is some data. So these are the CYP2C19 phenotypes. And I have probabilities for each phenotype. Here is some data about the CYP. Was it CYP2C19? Yes, CYP2C19. CYP2C19 gene. And the frequencies. Wait, wait, here's some data about the CYP2C19, their phenotype, and the prevalence of the different types in the prevalence of different variants in each ethnicity. Is this enough information to build a BaseNet? Oops, here's some data you break. You can specify the following variables in the Bayesian network. Oh, what is this? It's like suggesting how I could build it. That's pretty cool. The data you provide can be used to build a Bayesian network that models the conditional dependencies, the prevalence of different phenotypes in each ethnicity. However, you would also need to specify such as the relationships between. You could specify the following variables in the Bayesian network. CYP2C19 gene. This variable represents the different genotypes. Ethnicity represents the different ethnic groups. Phenotype. Then specify the relationships between them based on the known biology. Specify that this is a direct parent of the phenotype variable, and that is a direct parent for each given its. These could be estimated from the data. So while the data provides in it, here is the data. Is this enough information for you to write me a Python script that can be used in a Bayes net? Really? No way. No, I feel like this is not going to work. That would be really cool if it does, but I feel like this will not work because I don't even know what are we trying to predict right now. Are we just trying to predict the gene and the phenotype? I don't even know what are you trying to predict here? Maybe it's the phenotype. I don't know. What are you trying? It says models the conditional probabilities between the CYP2C19 gene and the prevalence of different phenotypes. Maybe the thing is like it doesn't really matter. You're just building a net, so you can kind of predict the likelihood. Yeah, maybe that is what it is in a Bayes net. The Bayes net, you can pretty much whatever the nodes are, you can predict the probability of an adjacent node or a couple nodes away, whatever is going to happen. Note this that the script assumes are known and have been specified. Each variable that are defined based on the given data, assuming that each ethnicity has a different frequency. The script also assumes that the PGMP has been installed. So what did you do here? So NumPy, pandas, define the variables. So we have CYP2C19 and ethnicity. You have your values. So yeah, here's our phenotypes that we are interested in. Here's your ethnicity. Create an empty Bayesian network. Add the variables from variables. So just two variables. Define the conditional probabilities for each variable. Is equal to tabular CPD. Where are you getting the variables from? State names, variable values for variable and variables. Card length values. So it's defined for the CYP2C19 for the ethnicity. I don't think this is right because I think this only shows up once. I don't know. Let's see what it shows. I mean, just quickly glancing at it, it feels like this is just, they're assuming this is the value itself, which is not. Add the conditional parameter. Let's just see what it does. No idea what this is going to do. Should be interesting though. Nope. Of course it failed. Oh, it's failed because I don't have I need to install. So pgmp. Where's my install? Maybe I'll just install here. So I don't remember the install syntax. I don't have installed. What is the syntax to install it? Okay. It's running. Values must be a 2D list array. I mean, I don't think what they wrote is actually correct anyways. Did I install it already? pgmpy. Once you've installed, you can try modifying the values argument to a 2D list in an array. Where's the thing? SIP2C19. Tabular CPD. It's right here. Variable card. Values. Where's the comma's out here. Just make sure, like this. Nice, fixing it. I just don't see where are the values. I don't even think they took my, like this is probably incorrect. 0.5, 0.5. The conditional problem. Just want to see if this works. Okay, let's try this again. Nope. Have them troubleshoot. Error definition, you should use a 2D array. There are 9 rows and 2 columns. Conditional probability for the SIP2C19 variable. Yeah. Oh, this is it. So it was assuming I had data somewhere. Where is that? Data list? For data and data list. Did you define that somewhere up here? Data list? Data list for ethnic group and ethnicities. There was assuming that you have a list. You can find data list as follows. Oh, okay. I think this is from my data. This would be really cool. So let me just double check on them. So Latino would have likely intermediate metabolizer. Likely intermediate. Likely intermediate Latino. This is what? 3? No, this looks incorrect. Likely intermediate metabolizer. This is saying 0.22. Let me look at another one. So let me look at this one. Sub-Saharan African is 0.04. Do they not even have all the ethnicities? Let's see if we can actually modify them. Let me grab this. Looks like your data, looks like your frequency table is incorrect. Well, assuming, what is that ethnicity data list? It looks like your frequency. The correct frequencies for each ethnicity. Can you modify the script to use those frequencies instead of yours in data list? Actually, a better idea is to use the API to grab this data. That actually would be a better way of doing it. Using the API to grab the frequencies instead of loading it manually like this. I'll try it afterwards. All right. Also, I have no idea. Or is it loading? Oh no, it's still doing whatever. Also, if anyone's in the chat this late, while we're waiting for this, let me know who you are. If you want to say hi, where you're from. Be nice to just know who's watching at almost midnight on a weekday. Or maybe you are watching afterwards, because it's live streamed and it's recorded. I think it stops. Oh no, look at that. Look at that. Load the frequencies from the JSON object you provided. This is super cool. Okay. JSON loads. Let's try this. So if I go back up, let's just move this up here. Frequency data and frequencies equals data frequency and data lists. Data lists. Is that how you had it? Data lists? Yeah. Say what? Let me see. Maybe what I need is this to be up top, maybe. Oops, nope. Let me just recopy this. Try it up here. While scanning string literal. I don't know what this is. Seems like some of the characters got cut off. Oh, there's probably just a lot of data in here. I didn't think this was that much. It's like 114 lines. This is really cool though. Maybe what we'll do is, since this is taking create a dictionary. Oh, there's more to it. So you load, what they're doing is you load the data and then you create a dictionary of it. So frequency data result, update the data list with the new frequencies. Wow, what is this? Where did you get this? What? Data list with the new frequencies. Create a new list. Why? I'm confused as to why only European is in your code section about updating about the data list. Can you explain? I'm just wondering why is it only Europeans in this section? I'm wondering if I missed the other ones. Only included the frequency. For item in the code iterates through each item in data list, which contains the original frequency data for each item, extracts the frequency data as a dictionary. If the ethnicity from the new matches an ethnicity, the frequency value for ethnicity updated. Nice. Wow, this is so weird. Why would it only give me European? Can you rewrite the entire code for building out this frequency data and data list? This looks nicer. Yeah, because this is pretty much my data here, which I think the goal is when I optimize it is not to be hard coding this, but rather to just pull this from the API. This is actually it's a decent amount of data. It'd probably save some time instead of having it write this whole out anyways. It's pretty cool though. I think it got cut off. Let's continue. Update the data list with the frequency data. Write the updated list to a new JSON file. Frequency data is added to the corresponding result. I'm not sure if it forgot about this section. Let me actually ask it this. Are you able to... Actually, you know what? This is a little too much. Why don't I just start with the API call? Instead of building the frequency table with the raw data, can you actually grab the data via CPIX API? Here is here's the API. Here is the working API get call that retrieves the frequency tables for SIP2C19. Way easier. Oops. Need to turn on the lights again. 1 second. All right. In this code, we use request. This is so much cleaner. So we are grabbing all the data. We're loading here. We create the frequency table by iterating through this. So for each item in data, we grab the result, which is the phenotype. We grab the result and the item of the frequency data result equals frequency, create the data list for a result. This is creating a frequency table, and this creates a data list. Data list append result frequency. I don't understand how this gets used in the Bayes. I know like one of them needs to be used. I don't know why they have a table and a data list. In any case, it's let me actually have it added to this. This is perfect. Let me actually try this code out by itself. Just to make sure it works. Yeah, this looks like it works. Let me just try a poll print. Yeah, looks like this is in a list. How does this differ from the frequency data? This almost looks the same. For item and data, result and frequency. Okay, so this works. Let me see if I can have it combine it with this code. Oops, not here. That worked. Can you now combine that code with the previous code I had for building the Bayes net? Load the frequencies. No, I don't want to do that. Did I have the... Oh, no, that's not what I want to do. I need to get rid of that piece. I didn't want to load the heart. Yeah, I didn't want to do this. I don't want it to load that. This code is perfect. Can you now combine it with my previous code, which is now here? check if the model is valid. I think it's here. I mean, if this works, it's kind of mind-blowing. Super cool. So getting the data from the API, you're creating the frequency tables from it and the data list, define the variables. This is what goes into the BaseNet. And yeah, so maybe it's like vice versa. So given the ethnicity, you can predict the likely phenotype, or vice versa. Given a phenotype, you can predict the likelihood of the ethnicity. And I guess in this case, it would be the most likely one. What we're interested in is predicting the phenotype, though, given the ethnicity. The code will retrieve the frequency table from the CPIC API, create the Bayesian model, and add conditional probabilities. So it's based on the retrieval finding. It will check whether the model is valid. If this works, man, super cool. Super cool. I'm like yeah, definitely not working the first time. I really hope this works though, because this might be it. I've been streaming a little too long too. I should probably be going to sleep. Looks like the error is occurring in the loop where you're trying to assign the frequency. Table is defined with only one column of values. You can modify a loop to assign frequency to the rows. Perfect. Can you now rewrite the entire script with that modified code? Yadish says hi. What's up, Yadish? Sure, here's the modified code. I don't know what they said the error was again. Where you're trying to assign the frequency values to the CYP2C19 table. It's defined with only one column of values corresponding to different possible states. You're using a two-dimensional index, which is causing an index error. Bayesian add nodes from variables. You have two nodes. So it's like CYP2C19 and likely phenotype. Okay, let's see if that worked. This is so crazy. I'm disappointed, man. I really hope this works. Looks like this shape, because I think I only passed the point where I really know how to troubleshoot this. Is not correct. The error the expected shape is 8.1, but the actual shape is 8.9. For each has not been normalized. What did you do? You can try modifying to normalize the frequency so they sum up to 1. I think this is actually going to be bad. You shouldn't be modifying the actual data. I don't recall any like modifications you had to make. That's a little disappointing. Hopefully this works. Define the conditional probabilities for ethnic group. Note that I had to modify the shape of the values to match number. So this code would probably be not appropriate to actually use, but I'm just want to know if it works. Nope. Oh, ChatGPT. This will assign frequency values. It's pretty interesting, like how it troubleshoots. I don't understand why it doesn't do it correct the first time. This is super interesting. It even like removes some of my ethnicities of interest. Let's just see if it works. Oh, come on, man. You can do better than this. Okay. Well, this is unfortunate. I think I might actually stop here. Yeah. I'll continue looking into this tomorrow, but this is definitely promising. I think there may be something here where we can like do that kind of prediction. So, all right, guys, if you were watching to the end, thanks for tuning in. Hope this was interesting as you guys think about your own use cases on how to use ChatGPT, or if you're interested in pharmacogenetics, seems like a pretty cool tool to use. Yeah, so I'm gonna head to bed. See y'all